Welcome to this tutorial on the Tagged Animal Movement Explorer, or TAME. In this video, we'll walk through how to create a new project. Each project consists of a dataset and a series of settings and options that define how that dataset will be loaded and displayed in TAME. We'll start by clicking the New Project button, which brings us to this multi-step form. The first step is to load our dataset containing the observed locations of our tagged individuals over time. Here's an example dataset of brown trout in the Deerfield River, which we'll be using for this tutorial. Each row corresponds to an observed location of one individual at a single point in time. And usually, there will be multiple rows for each individual, representing its movement over time. The dataset must contain, at a minimum, these first four columns, specifying the individual or tag ID, a timestamp, and the latitude and longitude. The ID can either be a sequence of numbers or a string of characters. The timestamp must be provided in year, month, day, hour, minute format, which is the ISO standard. By default, Excel may use a different format, like month, day, year. So we need to apply the correct format by selecting the values in this column, going to the Format Cells option, selecting More Number Formats, then Custom, and entering year, 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 month, month, day, day, hour, hour, minute, minute. If seconds are important to your timestamps, then you can include those also. The latitude and longitude columns must both be in decimal degrees and not degrees, minutes, seconds, and the longitudes should be negative for locations west of the central meridian, such as the United States. In addition to these four, the dataset can contain any number of columns for other attributes about each individual or observation. Here, we have the tagging site, fork length, and a column representing whether each observation was made during the day or at night. For missing values, TAME will only use blank cells. So make sure that if you have any missing values, especially for numeric columns, that you leave the cells blank rather than using something like NA or -999. And lastly, the columns can be in any order, and you are free to use whatever column names you wish, so long as there are no duplicates or blanks. If you export your dataset from R, make sure to exclude your row names, since that will be an unnamed column. TAME can only load a dataset in comma-separated value, or CSV format. In Excel, we can export to a CSV file by going to File, Save As, and then choosing CSV format. Note that there may be multiple types of CSV formats listed. If you have any problems loading the file into TAME, then I would try one of the other CSV options. Also note that if you close this file and then reopen it again in Excel, it will automatically change the datetime format back to month, day, year, or whatever your default is. So if you intend to resave it, make sure that you set the datetime column back to year, month, day format first. Now that our dataset is in a properly formatted CSV file, we can go back and load it into TAME. So we click here, choose our CSV file, then TAME will attempt to read this file, and if successful, provide a summary including the size, number of rows, and column names. So be sure to review this information to make sure that your file was read correctly. So everything looks good, so now let's continue on to the next step. In step 2, we specify the column names corresponding to each of the four primary variables. TAME will take an educated guess at which columns go with which variable. So here, it has already selected datetime for the timestamp and the latitude and longitude columns. It does not, however, guess the individual or tag ID column. So we have to select that manually from the list of all column names. Once we're done with that, we can click Continue, and TAME will check that each of these columns contains properly formatted values, such as the timestamps in year, month, day format. And we did not get any errors, so now we are at step 3, where we configure the additional columns in the dataset. For each additional column, we need to tell TAME what this variable is and how to use it. On the left is a list of these columns, which include all of the columns that were not assigned to one of the four primary variables in the previous step. A green check mark indicates that the variable will be included in TAME. And we see that by default, TAME will include all three of our additional variables. For each of these, we can provide a more informative label instead of using the column name. And then the second option defines what type of variable this is, either discrete or numeric. TAME will attempt to guess the variable type based on whether the first value of this column is a number or not, but sometimes it guesses incorrectly, such as when a categorical variable is represented by integer values such as 0 or 1. Next, we tell TAME what options this variable can be used for. By default, TAME will include each discrete variable as an option for the map color variable and for the cross filters. Discrete variables can also be set as options for the outline variable. However, TAME will only allow a variable to be used for outlines if it has only 2 unique values. For this tagging site variable, there were 10 unique values, so TAME throws an error. And whenever there is an error, TAME will also mark that variable with a red X on the left. So to get rid of this error, we can just unselect the outline option. Lastly, sometimes we might want to exclude a variable altogether. In that case, you can click the Exclude Variable option, and TAME will simply ignore this column when it loads the dataset. Note that excluded variables are marked by an empty circle in the list on the left. But we want to keep this variable, so unselect this option and move on to the next variable. First, we'll give this one a more descriptive label, and then we see that TAME correctly guessed that it is a numeric or continuous variable. Therefore, this variable can be used not only for color, but also for the size variable, which TAME selects by default. However, it cannot be used for the outline variable since it is not discrete. The last variable, for day and night, is a discrete variable, but now, since it has only 2 unique values, day or night, it can be used as an outline option. Now that we've gone through the additional variables and do not have any errors, we can continue on to the 4th step for dataset aggregation. Like most software, TAME may become sluggish or even crash if you try to load too big of a dataset. From our initial testing, datasets with fewer than 10,000 rows seem to perform reasonably well across a range of computer hardware specs. Larger datasets that had tens or hundreds of thousands of rows started to cause problems. However, in many cases, these large datasets contain high-frequency data where the locations were recorded at sub-daily or even sub-hourly intervals, say every 15 minutes. And since it's usually the larger scale movements that are of interest, aggregating the dataset to daily time steps can reduce the number of rows while also preserving large-scale spatial and temporal patterns. TAME provides 3 options for dataset aggregation. The first option is to perform no aggregation, in which case all of the rows of the dataset will be loaded into TAME. The other options provide 2 alternative ways of aggregating the dataset to daily time steps. The first will load only the row with the longest distance to the next location on each day and for each individual. Using this option ensures that TAME loads the observations associated with the largest movements on each day. Alternatively, the other option will load only the first row of each day and for each individual. So this option makes sense if you want to use a more consistent aggregation method across all days. If the raw dataset has less than 10,000 rows, then TAME will notify you that the aggregation is optional. But if you have more than that amount, then TAME will instead recommend that you choose one of the 2 daily aggregation methods. And sometimes, even with daily aggregation, a dataset can still be too large for TAME. If TAME finds that there will be 10,000 or more rows even with aggregation, then it will issue a warning. You can either continue to use TAME at your own risk, or go back and reduce the size of your original dataset. Some common ways to do this would be to only include a subset of the individuals, or to focus the dataset on a shorter period of time. In this case, we have a relatively small dataset with only about 3,000 rows, so we'll select the None option and continue to the final step. TAME has now checked our dataset along with all of our settings and did not find any errors, so we can click Finish to load our new project and start using TAME. At this point, the project has only been created locally within the web browser. None of the data or associated information has been sent to the server. So if I were to close my browser, then this project would be lost, and I would need to go through this process again to recreate it. But instead of that, I can save the project to the server, which will let me return to it later and also share it with other users. And if I want to update the dataset or change any of the settings, I can edit the project at any time. Please see the next videos on saving and editing a project for more information.